Welcome to Tanu Science. In this video, we'll learn the compound microscope. This is book back question, long answer type, fourth one. Explain the construction and working of a compound microscope. First, we'll see what is compound microscope. By using simple microscope, you can see the small objects. If the object is very tiny or very small, we can use the compound microscope. So compound microscope used to see the tiny objects. Its magnification is more than simple microscope. So how many times is more than 50 to 200 times more magnification power than simple microscope. So its magnification is high. Now we'll see the construction. A compound microscope consists of two convex lenses. One is objective lens, another one is a high lens. This is the principal axis. Objective lens is near the object. So this is AB. AB is the object. So lens placed near the object, hence it is objective lens. This is high lens. This high lens is placed near to the observer's eye. This is observer's eye. So that this is high lens. Objective lens focal length is very small or shorter, but lens with larger focal length and larger aperture is a high lens. So high lens with larger focal length and larger aperture. For this one, shorter focal length. Both the lenses are fixed in a narrow tube. The tube is not shown in the figure. So both the lenses are fixed in the narrow tube with adjustable provision. Adjustable provision means we can move the lens front and back. So we'll see the points how to write. So first one, objective lens. This objective lens, the lens with the shorter focal length is placed near the object. This is lens with the shorter focal length placed near the object. Hence it is objective lens. Then second lens is high lens. High lens, or you can say eyepiece. The lens with larger focal length and a larger aperture placed near the observer's eye. Now lens with larger focal length, larger aperture is placed near the observer's eye. Hence it is high lens, or you can say the eyepiece. Both the lenses are fixed in a narrow tube with the adjustable provision. So we can move this lens front and back for our convenient view. Now we will see the working of compound microscope. The object AB is placed at a distance greater than the focal length. We know that this optic center, this is principal focus. The distance between optical center and principal focus is focal length. So the object should be placed slightly greater than the principal focus or focal length. So you should keep beyond the principal focus. Now object is placed as AB. Due to refraction of this shorter focal length lens, image will be formed behind the lens. We know that rules: if a ray travel parallel to the principal axis, after refraction it will pass through the principal focus. If a ray passing through the optic center, it won't get any deviation. This is second ray. Now refracted ray is meeting at a point. That point gives the position of image formed by objective lens. This is A dash, B dash. This real and inverted image is formed in the magnified way. This image acts as a object to the eye lens. The image formed by objective lens is act as a object to the eye lens. This is a parallel ray to the principal axis. After refraction, it will pass through the principal focus of the eye lens. Then one more ray, if it is passing through the optic center, it won't get any deviation. If we extend this refracted ray, we'll get the position of the image. This image is considered as a final image. This is A double dash B double dash. This A double dash B double dash is a final image in the magnified way, visual and erect with respect to this image, but object and final image formed in the same side. Now we'll see the how to write for exam. So first point, the object AB is placed at a distance slightly greater than the focal length of objective lens. The object AB is placed at a distance slightly greater than the focal length. Next, this lens forms real, inverted and magnified image as A dash B dash is formed at the other side of the objective lens. So this real and inverted image is formed at the other side of the objective lens. Third point, this image behaves as the object for the high lens. So the position of the high lens is adjusted in such a way that the image A dash B dash falls within the principal focus of the high lens. The image behaves, this image behaves as the object for high lens. The position of the high lens is adjusted in such a way this image falls within the principal focus. So this image should be in the focus. Here behind the focus or behind the focus, beyond the focus, but here image is within the focus. We have to adjust this high lens. Then last point, this AI lens. The high lens forms a virtual enlarged and erect image A dash double dash B double dash on the same side of the object. So this eye lens forms virtual erect and magnified image same side of the object. Thank you, students.